All right, hello everyone. Today we're on section 8.7, 10.7, I guess, in our book. So what we've done so far is learned what power series are and when they converge and when they diverge. So what we're going to do the next three sections kind of together is talk about how we use power series, like what are they for, and so on. So our main emphasis is going to be on how to take a function and write it as a power series. It allows us to do computation with it. That's a skill that was really important before there were calculators, but even now some calculators are actually programmed with power series. Like you can write sine x as a power series to find the value of sine of 45 degrees. Often at the beginning of this, it's a little bit weird. It's hard to make all the connections until we're done with three sections. So kind of bear with it. We'll talk about it in class each day. It kind of gets a little jumpy at the beginning, but it all kind of comes together after three sections. So today is some basic ideas to how you can manipulate power functions. Ultimately, we're going to show you how to write the power function. So how to take like sine x and write it as a function. That's what our ultimate goal is going to be. We're not going to quite get there for a couple days. So the first thing here is, let's just say we have a power series. So remember, a power series is basically, if you were to take off this like little x to the n right here, this is what we've been dealing with all chapter, right? That a sub n, it's just a series, some series, whatever it might be. But then we tack on the x to a power. It's an increasing power is x to the 0, x to the first, x to the second. So this is what's called the power series. We're going to learn how to manipulate power series to write as a function. So right now what we're going to try to do is just we're going to work backwards. So ultimately what we're going to do is take a function and write it as a power series. To introduce you to that idea, we're going to take a power series, which you see right here, 1 minus x plus x squared minus x cubed, so on, and write it as a function. It's not the way we're normally going to do it. It's backwards, but then it's going to allow us to kind of give you some ideas. So I'm going to kind of go through this a little quickly. If you notice, this is just a geometric series, right? So this is just a geometric series. We're multiplying by negative x every time. So that means the r is common ratio is negative x. So that means it's going to converge if x is between negative 1 and 1. We've learned that a geometric series converges if its common ratio is between negative 1 and 1. So because we know it converges under those conditions, we actually know what it converges to, right? It converges to the first term over 1 minus common ratio, something we learned at the beginning of this chapter. In this case, the first term is 1. The common ratio is negative x. So it converges to 1 over 1 plus x. So what that means is this function up here is actually equal to 1 over 1 plus x. All right. So this is our first power series. What we have right here is the power series for 1 over 1 plus x equals, and we can write it as a series, right? It's equal to, it's a geometric series of the common ratio, first order of 1, a common ratio of negative x, right? So it's negative x to the n. If we start at, I guess, 0, I'll be careful with that. Because negative, I got to be careful with that because, yeah, positive, then we put in 1, it'd be, yep, so I think that's the power series. Okay, we don't need the 1, it's just negative x to the n, right? So what we're going to do today is just manipulate some power series. So we're going to learn how to write this the other way. This was weird because I just backtracked it. So in essence, really what I'm doing is just telling you that power series. I kind of showed you where it came from. Ultimately, we're going to take the function, the 1 over 1 plus x, and learn how to write it as negative x to the n. That's what's coming next. But not today. It's another section. So we're going to manipulate. It turns out, whoops, there it is again. Sorry, I don't need it there again. So what I'm going to do is just a couple little tricks. You might not understand why until just a second. So I'm going to take the derivative of both sides. So I have this power series written right up here in the green, right? 1 over 1 plus. So I'm just going to take the derivative of both sides. So that's that first step. The derivative of 1 over 1 plus x is negative 1 over 1 plus x squared. And then I just took derivative term by term. The derivative of 1 is 0, negative x is negative 1, x squared is 2x. And the last one, that power is going to drop, right? N times x to the n minus 1. I'm now going to multiply it by negative 1, both sides. You'll see why in just a second. That was a little bit weird. So that's just multiplying it by negative 1. All right, so basically I have another power series right now is what I have. Right now I have a power series for 1 over 1 plus x, where the idea is you can take a pre-existing power series and do some math to it, whatever that math is, and generate another power series. So now we have this power series for 1 over 1 plus x squared. Again, we're going to learn how to write that another way without having that intermediate step of the old one. But for now, we have a power series for 1 over 1 plus x squared. All right, so now I'm going to ask you a question. So now I'm going to try to have you write a power series. So all the power series that you're going to be asked to write tonight are going to be related to ones you already know. So now we know a couple. So let's say I ask you to write a power series for the natural log of 1 plus x. It should say 4. Oops, sorry. Ultimately, I'm going to show you another way, but the other way is kind of long and drawn out. Actually, you'll see when we get to it. So this way is kind of cool. If you have a pre-existing series that you can use, you can do it. So what I'm going to ask you to notice is that if I integrate 1 over 1 plus x, that's the same thing as the natural log of 1 plus x, right? So when I'm asking you to find the power series for the natural log of 1 plus x, I can go back to my original series, okay, and just integrate it. So what I'm going to do, sorry, there should be an intermediate step in here. So what I'm going to do is, if we go back to the one, this one right here in the green, right, equals 1 minus x plus x squared plus x cubed. Whoops, I lost a minus sign there. Plus minus. So notice if I integrate both sides, I'm going to get this, right? X minus x squared over 2 plus x cubed over 3. So I can take a pre-existing series that I know, take its derivative, I can take its integral, I can multiply it by a number, all that sort of normal algebra stuff that you would do to find new series. All righty. So there's a couple theorems that I'm just going to blow by really quickly. Just kind of ignore this. I know I'm going to go really quick. This just basically says you can take the derivative term by term. All right. So it says we have a function. So if you notice up here, I got a function and x to the n. If I take its derivative, it's just the same thing as taking the derivative term by term. And there's the derivative. This would drop the power, n times a sub n is a constant, x to the n minus 1. And you can do the same thing for those. You know, I know I'm going through fast. You're probably going, whoop, sorry, forget about that last step there. You're going, what's he doing? I need some help. But it doesn't. The idea basically is if you have a pre-existing series, you can take its derivative term by term to get a new series, or take its integral term by term to get a new series, or multiply it by the same thing term by term, or even use a composite function, which we're going to show you right now. So the next question says, and they're kind of leading you into it, use a power series representation for 1 over 1 plus x to obtain a power series representation for 1 over 1 plus x squared. Oops. So the idea, and I'm not going to go through the whole example, the idea would be this, right, is that we know that 1 over 1 plus, if we do this, watch, oops, sorry about that. If we go 1, gosh, I'll get it. If you take the derivative, so we start with 1 over 1 plus x. So we know that that theorem, if we go back here, right, 1 over 1 plus x, there it is, right, is this right here, negative 1 to the n, x to the n. So I'm just going to write that, negative 1 to the n, x to the n, which is also, whoops, which is also 1 minus x plus x squared minus x cubed, dot, 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 right? So now if I want to get this power series for 1 over 1 plus x squared, I need to know the relationship. So if I take the derivative of 1 over 1 plus x, so in essence, I'm going to prime this, and I'm going to prime that, you're going to get negative 1 over 1 plus x squared, right? So I take the derivative of this, which is negative 1. That's just a constant. The n's going to drop, x to the n minus 1. I can also do it term by term, right? 0 minus 1 plus 2x minus 3x squared. And then I wanted 1 over 1 plus x squared, not negative 1. So I just multiply everything by negative 1. Make that positive. So this is going to be negative 1 just times another negative 1, right? So n plus 1 and x to the n minus 1. And then this would be 1 minus 2x plus 3x squared. So this would be your power series representation. So you take one you already know and you manipulate it. So we need to give you some more. So here's one for you. E to the x. I'm going to write it this way for you. E to the x. We're going to show you how to get this later on. It's just x to the n over n factorial. All right, we're going to show you how to get this later on. So now I'm just going to show you how to find another one, like x times e to the negative 2x. So we're going to show you how to manipulate the original one to get this one. Okay. First thing you can do, the x is just a variable, right? So when I say e to the x here, right here, e to the x, it's really like e to the box. Whatever's in that variable goes in the other chunk. So if I want, there's my e to the x. I'm going to start with the e to the negative 2x. I'm trying to find x e to the negative 2x, right? So I'm going to start with e to the negative 2x. So what I'm just going to do is plug that negative 2x in wherever I see an x. Okay, x is just a variable. E to the whatever equals, notice, e to the whatever equals whatever to the n over n factorial. So that whatever in this case is a negative 2x. So the one staying constant, that x became that should be a negative 2x. Then I put x squared, negative 2x, then I cube it, and it's just going in this. Or I can just do it generally. I don't even have to do it term by term. Just throw it in the general term. Boom, negative 2x to the n over n factorial. And now I want x e to the negative 2x, so I just multiply everything by x. Okay, so I multiply everything by x. And again, what's really important is just that last term. So notice if I start with e to the x equals x to the n over n factorial, e to the negative 2x becomes negative 2x to the n over n factorial. And then x e to the negative 2x becomes negative 2x to the n times x. You can just do it all with the general term. Now I should probably simplify that because I got x's there. So we'll go negative 2 to the n and then x to the n plus 1 because we have x to the n and x. So I took my original one, which I gave you. So at this point, we only know a couple, just the ones in this video, the natural log of 1 plus x, 1 over 1 plus x. You know those, so you can use those in tonight's homework to do that. You can also use power series to approximate. So last thing, I promise. Let's say I want to approximate, oh gosh, that was bad, sorry, e to the, let me rewrite this, 0 to 1, e to the negative x squared. Let's say I want to approximate that. I can just use a power series to approximate that. So, like there's no way for me, I could use this on a calculator, of course, but pretend you don't have a calculator. You can't do this integral. I have no way to integrate this. U sub won't work. Integration by parts won't work. There's no method for solving this. So what I'm going to do is write it as a power series. So that e to the negative x squared is, I start again, sorry, I guess I should start with e to the x equals, just so you can see it, x to the n over n factorial. So I'm just taking that negative x squared and I'm plugging it in there, right? And that's why you see the negative x squared plus x to the fourth, so on. So this negative x squared is going in for my x's, okay? Or sorry, going in for my x's here. So now we have a power series. So now to estimate it, it just depends how much we want it to approximate to. How many terms? You just use the terms. Just go term by term. So it winds up being, once you integrate it, sorry about this, once you integrate it, x minus x cubed over 3 plus x to the 5th over 5 times 2 factorial. You just integrate term by term. It's just power rules. And then you would go from 0 to 1. So you plug in the 1 minus 1/3. So they would tell you how many terms or to what decimal point or something like that, right? All righty. So this is kind of a word section. It takes a little getting used to. It's really just using the pre-existing series. We have the geometric series I introduced you to at the beginning. Then you take the e to the x, the natural log of x. You can take derivatives and composite functions and that to find new ones. It's a nice, clever way if you already know one. So ultimately, we're going to show you ways to find them without doing this. But like I said, it's a little drawn out process. So this can save you a little bit of time and work. So I will see you in class tomorrow.